Okay, so in this problem here, one of the first things I always want to try and do is make sure that I recognize that between 9 and 10 is 69%. So this means this is 9 o'clock, and this is 10, 11, and 12, and 13, and 14, and 15, 16, 17, and 18. And so this must be 8. And so Paula has lunch from 1300 to 1400. Write down the probability that it rains. So the probability that it rains at lunch is going to be between 13 and 14 is going to be this value here, 27 equals 0.27. Okay, and the following parts may assume they're all independent, so that means that they don't affect each other. Paula needs to work outside between 10 and 1 and will also spend her lunchtime outside. Find the probability it will not rain. Well, these are all the probabilities that it rains. So the probability it doesn't rain is going to be 1 minus these all. So if this is going to be 46%, and this is going to be 31, and magically these are all the probability of not rain. So if I use good notation for that, let's say not rain, and rain. So find the probability it will not rain while Paul is outside. Well, that's going to be the probability of not raining is going to be, she's there from 10 until 1 o'clock. So that is going to be from 10 until 1. And then she has her lunch from here to here. So it's going to be those 4 probabilities multiplied. So that's going to be 0.2 times 0.28 times 0.52 times 0.73. And if I multiply those all together, I get 0.0234 is the probability. Continuing, then find the probability that it will rain at least once. Well, this is the probability that it will not rain 0 times. So 1 minus the probability of 0 rains is going to be the probability of it not raining. So that means it's going to be equal to 1 minus 0.0234, which then I can see is 0.977, or 6 rather. And then finally, D part says, given it rains at least once while Paula is outside, find the probability that it rains during her lunch hour. So find the probability it rains at lunch, given at least once. Well, that means I'm going to take the probability of lunch and at least once over the probability of once. At least once. So using what I know already that the probability of at least once is 0.976. That is from this value here. The probability of at lunch and at least once, well, if I think about what I've done, that's this one here, right? Because this is within probably let me articulate what I'm trying to say. The probability of raining at lunch and at least once is just the same as probability of lunch. So that means then that I'm going to take that initial probability of 0.27 divided by the 976, and if I divide that, I get 0.276.